Hey, Algebra 2 students. Welcome to a Friday afternoon chat with Mr. Bomsey about log properties. Okay, so hopefully you'll watch this for Monday, and you'll have a bit of an overview of three of the crucial log properties we'll deal with in the next few weeks. So today we'll go through some very basic examples, and then hopefully in class you'll be able to apply these properties to more challenging problems. All right? So kind of a pretty low budget version of a video today. I have a handwritten sheet that I'll go through with you guys. So there are three key log properties. All right, the first one is the sum of two logarithms, which is written there, number one. I'm purposely not showing you the example yet. But no matter what the base is, in this case it's base 10, but it really does apply to any base. Okay, the log, as long as the bases are the same, that is, log x plus log z is going to equal log of the product x times z. Okay, so you can condense the sum of two logarithms to a single logarithm by multiplying the two arguments and condensing them into one. Here's an example. Log 4 plus log 25. Now, neither of these logarithms could you evaluate on their own, right? Log 4 is an irrational number, so is log 25, so you have to use this property, right? It becomes log of the product 4 times 25, which is 100, and log 100, as you know, is 2. Now, of course, if the problem were something like log 100 plus log 10, well, those two, log 100 and log 10, each can be evaluated in your head. They are 2 plus 1, respectively, so the answer would be 3. But you also could apply this property to that. 100 times 10 is 1,000, and log 1,000 is 3. So you don't always need to incorporate this property, but when the logs cannot be evaluated on their own, you do want to use this property, like in this first example. The second example I have involves some variables. Okay, so this is kind of obvious, but I wanted to just go over this because we did just have a unit on exponents. Just to remind you, log, if it was x to the 4th instead of just 4, plus log x to the 25th instead of just 25, the rules are the same. We would multiply the arguments to condense to a single argument. But in this case, because we're multiplying with exponents, we would add the exponents. So yes, the rule is still you're multiplying the arguments, but with x to the 4th times x to the 25th, the property of those exponents is addition, so we get x to the 29th as the new argument. Log x to the 29th, not x to the 100th as from before. All right? So a little bit of a difference with variables versus coefficients, and that always is the case. All right? Next property is with the difference of two logarithms. As you can probably guess, log x minus log z is going to equal log of the quotient, x divided by z. All right, so that's the second major property, also a pretty easy property to follow. And I have two easy examples, one with just numbers and one with variables. First example, log 50 minus log 5. Well, again, you can't evaluate either one of those logarithms on their own, so you have to apply the property. 50 divided by 5 is 10, so the new log you have is log of just 10, and log 10, you know, is 1. That is one example. And yep, you guessed it, the next one's going to involve variables. So we have a similar problem, but we are again dividing with variables, with exponents rather. X to the 50th divided by x to the 5th is going to be the new argument, and that is not x to the 10th, but it is x to the 45th. So the new answer will be log of x to the 45th. Okay? We use these properties more often than not when we're solving log equations. Okay, where you have more than one logarithm in an equation, which you'll see very soon. The first step is going to be to condense to a single logarithm and go from there. So knowing how to apply these properties is very important. All right? Next property is the log of a power. Okay, log of x to the 9th. See how the argument has a power n? Well, that power can be written as a coefficient on the logarithm. Okay, so log of x to the nth power is also written n times log x. So you can bring that argument's exponent into the coefficient, into the front. So one example is right here, which you already can see. Log of 4 to the 5th power can also be written as 5 times log 4. Okay? So that kind of problem, you wouldn't have a problem on its own that says that, but that is a true statement and that might help you. Okay, if you're asked to expand logarithms, you will be asked to write without exponents, so you have to know that that exponent can go into the coefficient. Another basic example would be this. Log x to the 5th power would be, well, 5 times log x. Okay? Both very basic examples, but here's one that's more challenging. The next example is a combination, or it involves more than one of the properties I've already shown you. It involves the first and the third property. Here's the problem. So the instructions would say to expand this logarithm. Those would be the instructions for this particular problem. So what we're going to have to use is, first of all, just our general knowledge of exponents. We have a product to a power, so we do distribute that power. So the real problem is log of 3x cubed y cubed, and we've got to expand that. So the way you do that, we kind of do the first property backwards. Let me remind you of this. The first property we did was the sum of two logs, writing them condensed as the log of a product. So we're going to go backwards. From this, we're going to go into this. Every factor of the argument gets its own logarithm if you're going backwards. So in this one, we would have two logarithms, log x and then plus log z. All right? In the problem at hand, we're going to have three logarithms because we have three factors. The coefficient, 3, and then each variable will get its own logarithm. So the first step here that we'll handle is splitting this up into three logarithms, all with addition because these are all being multiplied. Log 3 plus log x cubed plus log y to the third. All right? And then you're more often than not asked to write the answer without exponents. So to apply the third property, we just bring the exponent in to become the coefficient, and the answer is down here. That log 3 just gets carried down, and then we have 3 log x and 3 log y, just bringing those exponents in front. Okay? So this last one is just a little bit of an extension. It's just to apply two of the properties in one. All right, so these properties on their own, or these problems on their own, aren't so crucial, but when we get into solving log equations, you will see why we do this stuff. All right? Have a great weekend. See you soon.